Hello. My name is Sergey Mitrofanov, and I will tell you about the effectiveness of humic preparations in the pre-sowing treatment of spring wheat seeds. Currently, the plant-growing industry has found widespread use of exogenous substances with growth-stimulating activity. This is one of the most effective factors in managing the production process and obtaining environmentally friendly products of agricultural crops. Of particular relevance is the introduction of biological preparations on crops located near processing plants that need environmentally friendly raw materials for the production of dietary and baby food. Currently, humic preparations humates are widely used as growth stimulants and bacterial fertilizers. The presence of a wide range of functional groups, such as carboxyl, hydroxyl, etc. in molecules of humic substances in combination with aromatic fragments, determines their ability to interact with various types of ecotoxicants, such as metals, radionuclides and organic compounds, thereby reducing their toxic effects on living organisms and ecosystems. Due to these properties, humic substances play an important role in the migration of heavy metals, radionuclides and organic ecotoxicants, controlling their geochemical fluxes in the environment. Humic substances are capable of reacting with metal ions and minerals of the solid phase of soils, forming compounds of various stability. In this connection, the interest of researchers is largely associated with the interaction of humic substances with various elements, especially with heavy metals, which in high concentrations are pollutants of the biosphere. Forming stable complexes with heavy metal ions, humic substances largely control their migration and accumulation in natural and anthropogenic landscapes. The result of the complexation reaction can be a decrease in the mobility of metal ions during the formation of insoluble complexes with humic substances, or an increase in their mobility when interacting with low molecular weight fractions of humic substances. Humic preparations were obtained from milled peat received from lowland peat deposits using technological equipment developed by Federal State Budgetary Scientific Institution FNAC-VIM. Peat quality indicators were as follows: the degree of decomposition was not less than 25%. Mass fraction of moisture was 55–70%. Ash content was no more than 15%. Acidity pH of the salt suspension was 2.8–6.0. Contamination with extraneous impurities. Pieces of fleece, wood larger than 25 mm was no more than 8%. Mass fraction of mobile iron oxides in terms of Fe2O3 was no more than 1%. Mass fraction of humic acid's total content per organic mass was not less than 30%. Quality indicators of the studied humic preparation: pH loss, 7.9 pH unit, content of humic substances 55 grams per liter. Humate was studied in a field experiment against the background of the control and had the best performance in a series of laboratory studies. The field experiment was carried out in 2018 on Rima spring wheat. The soil of the experimental site was dark gray forest heavy loamy in granulometric composition with 3.65% humus in the arable layer according to Tiran. Hydrolytic acidity was 2.57, the sum of absorbed bases was 23.55 mg per 100 grams of soil, pH was 5.05, the content of mobile phosphorus was 19.8 mg per 100 grams of soil, mobile potassium was 14.7 mg per 100 grams of soil. The data of the field experiment were subjected to mathematical processing using Excel add-in for statistical evaluation and analysis of the results of field and laboratory experiments AgStat, developed by Stavropol Research Institute of Agriculture on the basis of the methods outlined in the manual by Dospakha B.A. Pre-sowing tillage was carried out in accordance with recommendations adopted for Ryazan region of the Russian Federation. The forecrop for spring wheat was white mustard for green manure. The seeding rate was 6 million germinating grains per hectare. The experiment was repeated 3 times. The size of the accounting area of the plot was 360 square meters. The type of experience was plot-based. The meteorological conditions were contrasting. In April, there was 40.3 millimeters of rainfall. That was 8.9 mm more than the long-term average annual values. This created a reserve of moisture, which subsequently ensured the emergence of friendly shoots of spring wheat. Sowing of spring wheat was carried out after cultivation on May 10, 2018 with SZT 3.6 seeder. During agrotechnical works harrowing was on May 5, 2018. Application of mineral fertilizers in the form of azafoski as a background 16%, NPK 60 kg of active substance. Cultivation on May 9, 2018. In the first decade of May, the average daily air temperature was within 19.9 degrees Celsius, which exceeded the long-term average by 9.6 degrees. The rainfall was 21.3 mm by the time of sowing May 10, that exceeded the long-term average annual value by 8.3 mm. During May, the rainfall was within 27.8 mm, which deviated by 12.2 mm from the long-term average annual value 40 mm. In June, rainfall was only 10.6 mm. That was 44.4 mm less than the long-term average annual value. The air temperature this month was within 20.3 degrees, that was 3.3 degrees higher than the long-term average annual values. The severely arid June led to the fact that the plants were greatly oppressed. Despite good seedlings, this led to a decrease in the formation of reproductive organs. The rainfall in the second decade of July at the time of milky stage of spring wheat was 40.7 mm, that was 18.7 mm more than the long-term average annual values. So, it improved the growing season of spring wheat. In August, there was a shortage of rainfall, being 35 mm less than the long-term average annual values, which had some positive effect on the yield of spring wheat. During the entire growing season of spring wheat in July and August, the air temperature was also warmer than the long-term average annual values. There are several approaches to the use of humates, which is explained by the diverse action of the humic acids they contain. Therefore, humates can be considered as direct fertilizers, as a means for improving the efficiency of mineral and organic fertilizers. As a plant growth stimulator, pre-sowing seed treatment is the simplest and most effective method of using humic preparations. Improving the sowing quality of seeds allows, without additional energy costs, fertilizers, pesticides, to ensure the proper growth of plants, reduce the negative impact of weeds, diseases, pests and, on this basis, increase the yield of the crop and the quality of the products obtained, and improve the ecological state of the field. The field experiment was carried out in 2018 on Rima spring wheat. The soil of the experimental plot was dark gray forest heavy loamy. During the research, phenological observations were carried out concerning the main stages of development. The research results showed that pre-sowing treatment of spring wheat seeds with humate increased the germinating energy and viability of seeds in comparison with the control. The number of seedlings was in the range of 279-308 pieces per square meter, that was 29 plants more than in the control. A similar picture was for the tillering coefficient, which was 2.1-2.8. One of the main limiting factors in the formation of the size and quality of agricultural crops is the efficiency of the use of moisture reserves by plants, which largely depend on weather and climatic conditions of the year. Plants often lack moisture associated with dry conditions during this period. When full sprouting, soil moisture was in the range of 22.8-23.6%, that favorably affected the growth and development of spring wheat Rima during this stage and contributed to the amicable emergence of seedlings. At the beginning of milky ripeness of spring wheat, the moisture content was in the range of 15.2-15.8%. At the stages of booting and earing, the increase in herbage was determined to characterize the formation of the yield. Analysis of the data obtained on the growth of herbage of spring wheat Rima showed that the treatment of seeds with humate before sowing on dark gray forest heavy loamy soil against the background of the use of mineral fertilizers NPK 60 contributed to better growth and development of spring wheat. A longer development of vegetative organs was observed in comparison with the control. Determination at the stage of milky ripeness, despite the decay of leaves, showed a small increase in the herbage in the variant with humate. That was 44.2% of the first time, 42.6% in the control. Spring wheat plants use more than half of their tops for grain formation. Therefore, to study the effectiveness of humate, it is necessary to consider the leaf area, as it follows from the results of studies by other authors. The maximum leaf surface of a spring wheat plant is, on average, formed at the stages of complete tillering and ear formation. Compared with the control, where the seeds were not treated with any humic preparation, plants treated with humate increased the growth of stems by only 1 cm and the length of the leaf by 0.3 cm. When treating seeds with humate, a slight increase in leaf area was noted. It was 22.7 square centimeters per plant, while in the control without seed treatment with the preparation had 21.9 square centimeters. The air temperature in the third decade of June was 25.4 degrees, the deviation from the long-term average annual was 7.3 degrees and the lack of rainfall total amount of 4.5 mm created conditions that influenced the accumulation of dry matter. The productivity of spring wheat leaves, expressed in accumulation of dry matter per unit of assimilation surface at the stage of milky ripeness, was the highest in the variant with humate equal to 33.1%, that was 0.6% more than the control with 32.5%. The release of carbon dioxide from the soil serves as an indicator of the rate of decomposition of organic matter. The maximum amount of carbon dioxide is released at the time of intensive plant growth. Analyzing the data obtained, one can say that in hot and dry weather the microbiological activity in the variant with humate is 0.6% higher than that in the control. The release of carbon dioxide from the soil is higher by 13.2 mg. According to the data of the structural analysis of spring wheat plants, the effect of humate on the number of plants for harvesting, quality indicators, the elements of the yield structure was noted. So, by the time of harvesting, plants, the seeds of which were treated before sowing with humate, had the most productive stems 456 pieces, that was 68 more than in the control. The weight of 1,000 grains was determined by full value and being filled of seeds. Above, it was in the variant where the seeds were treated with humate. The weight of 1,000 grains of spring wheat rima was 36.1 gram in the control, 36.5 gram in the humate variant, 0.4 gram more than in the control. The grain weight from 1 ear was higher in the variant with the treatment of seeds with humate 1.17 gram, while the control had 1.15 gram. At the same time, the number of grains in 1 ear in the variant with the treatment of seeds with humate was 31.1 pieces, while the control had 30.0 pieces. When determining the structure of the yield in spring wheat rima, the length of stems in the control was 2.4 centimeters longer than in the variant with humate. However, the ear length in the variant with pre-sowing treatment of seeds with humate was 0.3 centimeters more. The analysis of the yield data gives grounds to conclude that according to the set of indicators, according to the conditions of 2018, the variant with pre-sowing seed treatment with humate is the most effective, which ensures the 27.66 hundredweight per hectare yield of spring wheat rima. The increase in comparison with the control was 2.3 hundredweight per hectare with HCPO 5-1.17 hundredweight per hectare. The increase was statistically significant. The use of humate contributed to an increase in accumulation of dry matter in plants relative to the control by 32.5% and 39.0%, respectively. At the same time, according to the data of Podvyazhevskaya Agrochemical Service Station, the use of the humic preparation in the pre-sowing treatment made it possible to increase the protein content in spring wheat production up to 14.8%, while in the control it was 14.0%. Also, an increase in the content of nutrients in the grain, in particular nitrogen 0.46%, was established. This fact indirectly confirms the previously obtained data on the increase in the efficiency of fertilizers and the availability of soil macroelements against the background of the use of humic preparations. The effect of humic preparations on the sowing and yield qualities of the seed material was established in the course of laboratory and field studies. The strongest positive effect was obtained when treating seeds with reduced sowing qualities, which were quite common when harvesting seed crops in years with heavy rainfall, lack of heat, violations of harvesting technology, and seed preparation. The treatment of such seeds with humic preparations increased the sowing qualities, germinating energy, viability, growth strength,